Great. Thanks, Andy, for the introduction, and welcome everyone to Spark Summit East. It's awesome to be here in New York, with a very large audience. Summit is actually sold out of people, who want to learn about Spark, and I hope you'll learn about and see many exciting things today. One of the cool things you may not be aware of is, I think in the sense of the program we have for the event, this was the most selective and probably the best program we've ever had for a Spark conference. When we posted an event in New York, we weren't sure how many people would submit talks and how many would want to fly here to speak. But at the end of the day, we actually got 170 submissions for a one-day event where we could only fit about 34 talks. And it's the most sort of ratio of submissions to talks that we've had. To give you a sense, last year's Spark Summit in the summer was a two-day event, and we had something like 85 submissions for 50 talks. So the talks we selected are hopefully all really awesome, and I'm really looking forward to seeing many of them myself. So in my talk this morning, I'm going to say a little bit about what happened with Spark last year and the major directions happening for development in 2015, in particular things that we at Databricks are thinking about, but also things from the broader community. So let me just start with a little bit of things that happened last year. And last year, 2014, was a really amazing year for the open source project. To give you some sense, it was the largest year of growth for the project so far. And to give you some sense, so the number of contributors to the project, total people who had contributed to Apache Spark, was 150 before the beginning of 2014. And last year we had about 400 new contributors. The total number grew to 500. The size of the project, the code base, almost doubled. Most of this is because we introduced new libraries in Spark, which I'll talk about, like the graph processing library, for example. And we're aware of over 500 active production deployments of Apache Spark. To give you a sense of the growth, this graph here shows the number of contributors per month to Spark sort of throughout its history. And you can see, it's since, since 3 years ago, it's been going up quite steadily. So we have, in the past 6 months, we've had more than 90 contributors per month, which is a lot for any type of open source project, actually. Among big data projects, to give you a sense, Spark is the most active, as we can tell, in terms of people contributing per month, patches contributed per month, and so on. It's 2 to 3 times more active than any other project, including Hadoop MapReduce or Storm or things like that. And actually, among all projects at the Apache Software Foundation, it is currently the most active. So what did all these contributors do? They're not just sending in lots of patches, but there were some pretty cool technical advances in the project, which we hope to continue through 2015. So one thing that people might have seen is the improvements that went into on-disk sorting and large-scale behavior, and in particular the Apache Spark's entry into the large-scale sort record. So this is an industry sort of competition that people run every year, and the goal is very simple. You have to sort 100 terabytes of data. You can use whatever types of hardware you want, however many machines you want, and whatever software you want. You just want to sort it in the shortest time possible. So it's a pretty well-defined and kind of everything goes benchmark. So in 2013, the record holder for this was Hadoop MapReduce. This was an entry by Yahoo, which used a 2,000 node cluster, pretty new nodes from then, to sort 100 terabytes in 72 minutes. And since you can bring however many machines you want, this is basically people could throw in lots of machines and make it fast. In 2014, we at Databricks invested a lot of effort into optimizing Spark's performance on disk and on the network. We rewrote much of the networking layer, and we entered the test as well. And we were able to actually set the record in 2014, and we set it using only 207 machines. So using 10 times fewer machines and 3 times less wall clock time, we were able to set it. And this is all through efficient utilization of the disk disk hardware and the network in this cluster. The other really cool thing about this is that we did this in the public cloud. It's the first time this benchmark has been won by someone using the public cloud. And apart from the sort of performance benefits to the core engine, there have been many new libraries and additions added on top. Some of the major things that were added were Spark SQL and graphics, which are two brand new components that we added in last year. Support for Java 8 syntax, random forest among the many machine learning algorithms, and Spark streaming support for Python and for machine learning algorithms. There are actually some talks on this here today. So these are some of the things that happened. So what are we focusing on in 2015? There's lots of activity in the community, but at Databricks, looking at sort of the trends and what people want to do with Spark, we've identified two key areas that we're looking at. So the first of these is data science. We see Apache Spark being used more and more, not just by developers writing new parallel algorithms, which is kind of the initial use case, but also by data scientists and people looking to, as quickly as possible, sort of analyze a new data set. And to make this easier, we're building a new set of high-level interfaces to Spark, similar to single machine tools, such as the tools you might be familiar with in R or in Python, but that automatically run over a cluster. And I'll talk about a few of these, but these make Spark quite a bit easier to use for a much wider audience. The second thing that we're looking at is platform interfaces. So from the beginning, Spark was meant to be a pretty general compute engine where you could do different types of computing, and we wanted it to run well in many environments, ranging from Hadoop MapReduce clusters to Cassandra or the public cloud, most environments where there is data, because people store data in many different places today. And through these platform interfaces, we're making it easier to plug in data sources and algorithms into Spark so that every Spark user, every Spark application can run well in more places. So I'm going to just briefly talk about a few aspects in each one. Let's start with data science. First thing that we've done to make data science easier is the new DataFrame API, which actually shipped in Spark 1.3. It's available in all of Spark's programming languages, and it looks similar to data frames in R and in Python. Okay, it looks similar to R and to pandas in Python. One of the really cool things we do in this API is as you write your data frame computation, we actually optimize it using the same optimizer used in Spark SQL. So you get some pretty fancy optimizations happening to it, and we compile it down to Java bytecode, and then we run it on the cluster. So using this API, you can actually run faster than the native Python and Scala APIs, and it's also in many cases easier to use. Second thing in the data science space that is also started to be out in Spark 1.2 and continues to be improved is machine learning pipelines. So this is a higher level API for machine learning. It's built on top of MLlib, and it's inspired by scikit-learn and other sort of high level machine learning libraries. And it comes with built-in components for featureization, model evaluation, parameter search, like scanning a grid of parameters, that you can chain together into a pipeline, and then you can run these pipelines efficiently on a cluster. And it makes it much easier to build sort of real-world end-to-end pipelines instead of just calling one algorithm. And then the final thing in the data science space is support for the R language, or Spark R. This has been in development for quite a while, primarily as a research project at UC Berkeley, and we're aiming to merge it into the mainline Spark in June in Spark 1.4. So keep an eye out for that. It's actually a very active kind of community project with multiple companies contributing to it. And both the data frames and the ML pipelines I showed before will be available in R. If you're not familiar with R, this is code for using data frames in R, and it looks the same whether they're Spark data frames or the built-in R ones. So these are some of the data science things that we're doing that we think will bring Spark to even wider audience. Next, on the platform interfaces. Platform interfaces are really important for anyone writing an application to be able to run it in many environments and to move it around. And they're also important for people who build storage systems and things like that to easily run all the Spark algorithms out there. And I'm going to talk about two of them. So the first one, which came out and has been improved in Spark 1.3, is external data sources. We wanted to make it very easy to plug in data sources into Spark so you can use a wide range of storage systems that are out there. And we created this API to do that. The API actually returns data frames, which are structured data. And it's usable both in standalone applications and in Spark SQL if you want to run SQL queries against any supported data source. And one of the really cool things it does is that it understands the queries you're running on the data source, and it tries to push them as intelligently as possible into each data source to minimize the amount of work done. And this is really important when you have large data sets because it's expensive to move the whole data set around. So to give you an example of things you can do with it, databases like MySQL are one supported data source, and so are logs, for example, in Apache Hive, any table supported by Hive. And you could write a query using this API that's joining across these two things. So that's really nice because it's just a SQL query that's joining across them. But then the other cool thing that will happen is when Spark SQL looks at this query, it will realize that, okay, in the users table, you're only selecting users whose language equals English. So when it talks to MySQL, it's going to send MySQL a query that only selects those users who are speaking English. This is called query federation. And by doing that, you really minimize the amount of work done to get the data out of each data source, and you can sort of intelligently use these even on a cluster. So this is out in Spark 1.3. It actually, an early version was there before, and both the JDBC data source and Hive are already supported. And then the final thing I wanted to mention in terms of the community and platform interfaces is Spark packages. We started this website of index of third-party packages that work on Spark. It's partly to tell the community what's out there, to have a single place to organize them, but also partly to make them very easy to link into and use with Spark applications, similar to packages in R or to packages in Python. And in Spark 1.3, we actually have syntax on the command line, even for the Spark shell. You can tell it to use specific packages. So for example, as a sample package, we posted a data source for CSV files that lets you treat them as structured data and deals with all the quirks of the CSV format. And you can just add that to your Spark shell using the command over there. Spark packages is still quite new, but there are 45 packages listed on the site. And if you're working on an interesting library, we encourage you to put it there to have people find it. So this has a tour of at least 5 of the features that we're working on or have already put out for 2015. So if we look at the Spark sort of stack diagram for 2015, it means there's quite a bit of stuff being built up. You have here, the core engine and the 4 libraries that we had before. First thing we're doing is on top of that, we're adding these data science libraries, DataFrames and ML pipelines, which I think will make Spark actually, many times quicker to use for a lot of the common use cases in data science. So this is the first thing we're doing. Second thing we're doing is adding these data sources, and there are quite a few data sources in development from the open source community. These mean that all the code you write on top of this against data frames or against ML pipelines can run over all these interesting sources of data, which is pretty cool because you don't have to change your application to use them. And finally, on top of this, we will be able to support the 4 most popular, most commonly used programming languages for large-scale data analysis. So Scala, Java, Python, and now R as well. And so all these things, kind of build on each other. Any of these languages can use any of these libraries and talk to any of these data sources. And building this kind of unified stack for data processing that lets you merge data across many different domains has long been the goal of the Spark project. So basically, we want to give you a single unified engine you can use for all your data processing work to simplify the work of doing different types of data analysis on different sources. And that's still the goal that we continue to work towards. So that's pretty much all I wanted to say. There's a very exciting program ahead of you, and I want to make sure you get a chance to see it. And if you miss any stuff, you can always find the slides and the videos of everything online. So thanks, and enjoy Spark Summit East.